Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Welcome back to my fun physics world. So today we enter a new chapter, chapter 4, heat. So in this chapter we have 4 subtopics. 4.1 thermal equilibrium, 4.2 specific heat capacity, 4.3 specific latent heat, 4.4 gas loss. So this is the mind mapping for this chapter. Alright, so today we will look at thermal equilibrium only. Stay tuned for my video on the other 3 subtopics. Alright, so the learning standard for this thermal equilibrium, number 1, explain with examples thermal equilibrium in our daily life. Number 2, calibrate a liquid in glass thermometer using 2 fixed points. Alright, but before that, these are the 3 important keywords in this thermal equilibrium. So number 1, temperature. So what is the meaning of temperature? Temperature is actually the degree of hotness. So this is the definition for temperature, degree of hotness of an object. So the unit for temperature is Kelvin. Okay, so Kelvin. So this is an SI unit. So the symbol for Kelvin is capital K. So a hot object is at a higher temperature than a cold object. So I think this one everybody know. Alright, next one, heat. So heat is actually a form of energy. So since it is a form of energy, so we measure heat by unit joules. Okay, Joule, joules. Okay, capital J. And then when an object is heated, it will absorb heat energy. As a result, the temperature of the object will increase. So it means that the degree of hotness of the object will increase. But when the object is cool, it will release heat energy and the temperature will drop. Okay, so there will be net heat transfer from hot object which has higher temperature to a colder object which has lower temperature. Okay, later we will look at this in more specific, alright? So now, what is the meaning of thermal contact? So when the objects are in thermal contact, so the heat can transfer between them. When the objects are in thermal contact, so the heat will be transferred between them. This picture here showing the hot coffee is in thermal contact with a spoon. Okay, so means that there will be heat flow from the coffee to the spoon and at the same time from the spoon to the coffee. Okay, we will look at this in more detail. Look at this diagram showing object P and Q is in thermal contact. P is hotter, higher temperature. Q is cooler, lower temperature. So when they are in thermal contact like this, there will be heat transfer from P to Q at the same time from Q to P. But since P is hot, so what happens is the rate of heat transfer from P to Q will be higher compared to the rate of heat transfer from Q to P. Okay, so we say that there is a net heat transfer from object P to object Q. Hence, temperature of P will drop and temperature Q will rise. Okay, after some time, okay, the heat transfer from P to Q and from Q to P will be equal. So in this case, we say that the net heat transfer between P to Q is 0. So we say that there is no net heat transfer between object P to Q. So when this happens, the temperature of object P and object Q will be the same. So in this, we call this as thermal equilibrium. So it means that thermal equilibrium already achieved. There are 2 important points here. Number 1 is the net heat transfer between both objects is 0. And then number 2, the temperature of both objects will be equal. So hence, we call this as thermal equilibrium. So when 2 objects with different degrees of hotness come into thermal contact, heat energy will be transferred between the 2 objects. Okay, object A, B. A is hotter, B is cooler. So the rate of heat transfer from A to B will be faster compared to from B to A. So in this case, we say that there is a net flow of heat from the hot object to the cold object. Okay, and then when thermal equilibrium is achieved, the heat transfer from A to B and B to A will be equal. So in this case, we say there is no net heat transfer. As the result, the temperature of the object will be equal. So in this case, we say that the thermal equilibrium already achieved. Make sure you remember, when two objects are in thermal equilibrium, there is no net flow of heat between them and they have same temperature. Now, how do doctors measure temperature of a human body? Okay, so the keyword to answer this question, number one is the word thermal contact. Okay, so temperature is placed under the tongue of a patient. Okay, so that there will be thermal contact between the patient's body and thermometer. So thermal contact between patient's body and thermometer, this is the first mark. Alright, then heat will be transferred from the patient's body to the thermometer and vice versa until thermal equilibrium is achieved. So this sentence is 1 mark and then thermal equilibrium is 1 mark. And then make sure you define the thermal equilibrium. So when thermal equilibrium is achieved, there is no net heat transfer from the patient's body to thermometer, and the temperature of the thermometer will be the same as temperature of patient's body. So this is how we confident, okay, saying that the temperature of the thermometer represent the temperature of the human body. When we are having fever, how do we remove heat from our body? So the way to answer this is nearly the same as the previous question. Okay, so number one, thermal contact. So you need to write about thermal contact. So the wet towel, or maybe use this one, the cooling pad, is placed on the forehead of a person who is having high fever. Alright, so that there will be thermal contact between the forehead and also the wet towel or the cooling pad. Then after a while, the towel will be hotter and you need to rinse the towel, but for the cooling pad no need. Alright, so point number 2 that is important will be heat energy is transferred from the forehead to the towel and vice versa until thermal equilibrium is achieved. Okay, and then you need to define thermal equilibrium. When thermal equilibrium is achieved, there is no net heat transfer between the forehead and also the towel. Okay, so the temperature of the forehead or the body will be the same as the temperature of the towel. So this is the way the heat will be removed from a person. Liquid in glass thermometer. So what is liquid in glass thermometer? So this is the normal thermometer that we use in our lab. Okay, so the characteristic of the liquid that is used in this thermometer, number one, it must be easily seen, means that it must be opaque. And then number two, the liquid must be able to expand or contract rapidly over a wide range of temperature, and it can expand uniformly when heated. And then number three, the liquid should not stick to the wall of the glass for the capillary tube. Okay, so how a liquid in glass thermometer works? Okay, so number one, the bulb of the thermometer contains a fixed mass of mercury. So this mercury volume will increase when it absorbs heat. Why does the volume increase? This is due to the mercury expands, okay, when it absorbs heat. Okay, so the length of the mercury column in the capillary tube indicate the magnitude of the temperature. So the higher the length of the mercury column, the greater the temperature. Let's say you join an amazing race. Your task is to measure the temperature of this unknown solution with this thermometer. So this is a liquid in glass thermometer, but the problem now is this thermometer has no scale. Although there is mercury inside, but then there is no scale for you to get the reading. So what should you do? Yes, you need to calibrate the thermometer first. Calibrate means you need to add in scale to the thermometer first. So how is it possible for you to calibrate the thermometer? So actually you need two scale. So one is, alright, so one is the melting or freezing point, okay, which is the temperature of pure melting ice. So the value of this temperature is 0 degrees Celsius. Then you need another point which is known as the boiling point, the temperature of steam from water that is boiling under standard atmospheric pressure. So this temperature is 100 degrees Celsius. When we place the thermometer in ice, the mercury will rise, and this is the length of the mercury when the temperature is 0. Okay, so this is the length of the mercury when the temperature is 0, so we label it as L0. Then the same thermometer, the one that not calibrated yet thermometer, is placed in the steam, and then the mercury will rise, and this is the length of the mercury when the temperature is 100 degrees Celsius. Okay, so you look at the starting, so here, see, so this is the length of the mercury when the temperature is 0, and then from here, this is the length of the mercury when the temperature is 100 degrees Celsius. So when we have the 2 point, so we can minus the length of the mercury when the temperature is 100 degrees Celsius, okay, minus the length of the mercury when temperature is 0 degrees Celsius. So the length in between here, you can divide into 100 equal divisions, hence you can calibrate it already. Okay, so let's say when you use the thermometer, okay, to measure the unknown solution just now, and the length of the mercury increase until this level, okay, so you can read this from the scale of the thermometer. By calculation, you can also calculate by using this formula. Okay, look at this formula. So we have the length of the mercury in the unknown solution, L theta, minus L0, which is this length, and then divided by L100, the length of the mercury when the temperature is 100 degrees Celsius, minus the length of the mercury when the temperature is 0 degrees Celsius. Then you times 100 degrees Celsius. Look at this example. So we have a liquid in glass thermometer that has not been calibrated. So when it is inserted into melting ice and boiling water, so the length of the mercury are 2 centimeter and 9 centimeter respectively. Now, when it is inserted into unknown liquid, the length of the mercury is 7.5 cm. So calculate the temperature of the unknown liquid. So which one is the L0? L0 will be this. L100 is this. And then this is L theta. So with that, can use the formula. Just substitute the value. So L theta is 7.5 minus L0, which is 2, divided by, okay, 9. This is L100 minus L0, which is 2, and then times 100 degrees Celsius. You calculate, use your calculator, you will get this answer. So it's better to let your answer into decimal place. Okay, the working principle of a thermometer. So when the thermometer is placed in contact with hot water or any object, so heat will be transferred from the object to the thermometer. So thermal equilibrium between thermometer and the object now, which is hot water, reach when the net rate heat transfer is 0. So the temperature of the thermometer and the temperature of the hot water will be the same. So at this point, the reading of the thermometer shows the reading of the temperature of the water. Normally, we use mercury as the liquid in a thermometer. So these are the characteristics of the mercury that make it suitable, okay, for that. So number one, it is a good conductor of heat. Okay, it can conduct heat efficiently. And then number 2, it has higher boiling point, okay, up to 357 degrees Celsius. Okay, and then the third one is it has lower freezing point, negative 39 degrees Celsius. So it makes that the mercury can be used to measure higher temperature object, okay, more than 100 degrees Celsius, and it can measure lower temperature object, okay, lower than 0 degrees Celsius. And mercury also can span uniformly when heated, and it is opaque, so it means that it can be seen easily. So these are the 5 important characteristics for the liquid that can be used as a liquid in glass thermometer. Remember these 5 important points. And then how to increase the sensitivity of the mercury thermometer. Okay, number 1, use thinner glass capillary tube. And then number 2, use thinner wall glass bulb, and then use smaller bulb. Let us do some exercise. For this exercise, I will advise you to read the question first and then think of the answer, then only proceed with this video. Okay, so question number 1. So which of the following characteristic is used in the function of a liquid in glass thermometer? Volume, boiling point, resistance, density. For this question, think of what is the physical quantity of the liquid that will change or increase or decrease when the temperature change. Yes, the volume. Okay, just like for the mercury, when mercury absorb heat, the temperature will increase, hence it will expand. Okay, when the mercury expand, so it means that the volume will increase. Since the mercury is in the stem of the tube, the capillary tube, so what happens is when the volume increase, the height of the mercury increase, which means the length of the mercury increase. So the length of the mercury in the liquid in glass thermometer represent the temperature. So the answer is A. Question number 2. So which of the following method can be used to increase the sensitivity of the mercury thermometer? A. Thick wall glass tube, thinner capillary tube, shorter capillary tube, larger glass tube. Which one? Thick wall glass bulb. So if let's say the glass bulb is thicker, hence the heat will need more heat need to travel through the glass bulb to increase the temperature. So the thermometer will not be that sensitive if you use thick wall glass bulb. Thinner capillary tube. Yes, yeah, this is the answer. All right, thinner capillary tube. So when the capillary tube is thinner, so the heat can flow faster to the mercury in the thermometer. Okay, so it's better to use longer capillary tube so that the increment in temperature will be more, so means that more sensitive. All right, so it will be it will change more when the temperature changes. Okay, larger glass tube also will not increase the sensitivity of the thermometer. Okay, last question. And alcohol in glass, yeah, alcohol also can be used as a liquid in glass thermometer. So an alcohol in glass thermometer has not been calibrated. So when it is inserted into melting ice and boiling water, the length is 5.2 cm and 13.7 cm respectively. So when it is inserted into a cup of warm water, so the alcohol length is 9.8 centimeter. So calculate the temperature of the warm water. Okay, so in this case, remember the formula. Right, remember the formula? This formula. So which one is L theta? L theta is here 9.8. The temperature that you want to calculate. And then L0 is the length of the liquid, now is alcohol, when the temperature is 0. So means that here 5.2. And then L100 is the length of the liquid when the temperature is 100 degrees Celsius, means that in boiling water or in steam, so 13.7. So with that you can calculate already. Okay, use the same method. So 9.8 minus L0, which is 5.2, divided by L100. L100 now is here 13.7 minus L0 5.2 times 100 degrees Celsius. You use your calculator, okay, and then you will get this as the answer. Alright, so we'll recap. So hopefully now you are able to explain with example thermal equilibrium in your daily life, okay? And then number 2, calibrate a liquid in glass thermometer using fixed point. Alright, so if you watch the video until here, please comment below the word thermometer. Alright, so till we meet again. Assalamualaikum warahmatullahi wabarakatuh.